Eric Jordan. He's the Southeast Business Development Manager from Clear Creek Systems, and he's going to talk about optimizing PFAS remediation strategies through rapid small-scale column tests.
Well, first and foremost, I want to say thank you for still being here. I am the last one, so as soon as I'm done, you can sigh the breath of relief there. So, I would like to start with just a brief little background on who we are as a company, because it's very relevant to what we say. Hold on, I got to pose. There we go. Sorry. Yeah, there's the agenda. I'll skip through all of this. We've been around for about 30 years, and we started doing solids management. And first of all, I want to state with this: we are not tied to a technology. We're not here to promote one type of technology over another. We use all different types, and basically we do what the engineers tell us to do. We are heavily involved in the evaluation process, and that's why I'm giving this presentation today, is we help the design, we do the piloting, and then we build the systems ourselves. So we're the hands-on group that when you decide that you have PFAS and you figure out how you want to treat it, you hire us to come build the systems for you. Without getting into all the different things about us, we've been doing groundwater remediation, we do DOD sites, we do all of these different types of PFAS, metals, and other types of contaminant removal. We're nationwide, we got all over the things, and as you know, that the water is different in every state. We have different pHs, different alkalinities, different contaminants. So we've been hit with just about every application you can think of and all the different variables that you can discuss. So PFAS obviously has just been ruling the world for the last 5 years, and you've heard a bunch of presentations on different ways to deal with it. But how do you optimize the system? So this is mainly focused on media. So whether you choose GAC, ion exchange, or modified clays like FluoroSorb, one of the questions is, A, what is the efficiency of it, and what is my life expectancy? Because if I put a normal column test out there, how long does a 4-inch column when you're running your test and everything, how long will it take to get to breakthrough? If you do the calculation on, say, GAC, and you put a 4-inch column, you got a 12-minute empty bed contact time, you can only run 5 full bed volumes through that an hour. Now, if you do the calculation, that's 833 days before you see breakthrough, before you can establish this. Well, how do you speed this process up? No, excuse me, I'm going to skip through some of this. You do it in the pilot, and yeah, okay. Once again, I'm going to get through some of this. The RSSCT, Rapid Small-Scale Column Test. That's the purpose of this measurement. It is not to really look at which technology is quote-unquote better or worse for your application. It is really meant to see how long will this media last? What is going to be my change-out? What is going to be my cost of operation? That is the short and sweet of it. You know, how much material at this concentration can I put through this before I see breakthrough and I have to replace it? Now, if I do that with traditional, once again, ion exchange, a lot of times you get 700,000 bed volumes. Carbon, you can get anywhere from 250,000 bed volumes. And then if you try to do that, you're years into this before you actually see the first verifiable breakthrough. And, you know, thousands upon thousands of testing. Dollars and just sending stuff off to the lab, and do I have it yet? Well, we can now shorten this whole process into less than 30 days. Well, how do they do that? Well, we take all the different granules that are, averaging between 10 and 22 millimeters, and we grind those down to 1 to 3 millimeters. Every manufacturer has their recommended for this, and we go to them and say, can you prepare us a sample for RSSCT? The manufacturer brings it to us. We put it into, and I thought I had a picture of a column. And maybe I skipped over that. So the columns are extremely small. So now, instead of being able to run 5 an hour, we can run 10,000 bed volumes through there every single hour. So that's where we're getting this. Now, one of the key factors, and I'm totally summarizing this because I know this is the last presentation. Because you are reducing the size to a known factor, there is an algorithm that you have to recalculate back up to a 20 millimeter size thing. So even though that we're running this, especially the media manufacturers, so, well, you only got 250,000 bed volumes in this. Well, that's not what it's going to be at full scale. There is a formula to calculate. This was a 1 millimeter size granule. You're going to be dealing with a 20 millimeter size granule. So there is a calculation that's very known and established in the market for this. So we just put that calculation, and that's how we can accurately tell you that your carbon or your ion exchange or your FluoroSorb is going to last a year. It's going to last 6 months. It's going to last 2 years. Whatever it is at your concentration, at your flow rate, the RSSCT is a very established way of getting that cost of ownership down. So now you have your media salesman coming in. We got the greatest thing ever. And they spill out the sales force. And now you have a way to verify that cost. Because now you get into what is the cost per pound? Well, I'm $2 a pound. I'm $4 a pound. I'm $6 a pound, whatever it is. Now all of a sudden you look at where do I see breakthrough? How often am I changing this out? How much volume am I going to be using? Because one media, you may need 12 feet. Another media may need 4 feet. You know, I've seen it, and a lot of this, one media is 2.5 times the cost, pound for pound, but it lasts 3 times as long, and you need 1/4 the volume. And that's where we get into these calculations and total cost of ownership. And that is all verified through an RSSCT. And I have really sped this up. I think I want out of here as much as you guys want. So in doing this, there is a very particular pattern in where I'm going to back up for this. As long as you understand the media, what we're grinding it down to, what the full size of the media is, and then how many total bed volumes we can put through there, that's how we establish the cost of ownership. Now, does that eliminate the need for a traditional column test? Absolutely not, because there's typically multiple variables. So a lot of times we will run the RSSCT in correlation with the regular column test, because what if you have TOC? What if you have other contaminants you want out, say metals or anything along those lines? Now, you still want to play with your water chemistry. That's what the traditional column tests are. It allows you to, without having to run it to breakthrough, you can still see removal and to see if these other variables affect the water chemistry as far as your alkalinity, if they're getting breakthrough, what are the removal rates. Now, there are ion exchange resins out there that are affected this way. They're like your organoclays, don't touch TOC. You've got hydraulics testing, which we run through. These are all the different types of variables that we're running in when we're running the pilots with our engineers. So there we go. Factors affect runtime. The type of PFAS, the media type, the water quality, test design, and your target bed volumes. All of these are performance. I have found that in this industry, I'm relatively new in this part of the industry. I'm 25 years into the water, wastewater world. But the RSSCT, I'm still having to explain it to a lot of people and the importance of it. And it seems like this would be the first test. If you're looking at media, if you want to evaluate what the overall cost is. Here in Florida, a lot of people are throwing nanofiltration or RO at their water on the drinking water side, because there are a lot of other co-contaminants, and it seems to be just what they throw at it. As you get outside of Southeast Florida, there's smaller plants, and it's also a volume issue. So as you get outside of this and you get into the other states, now all of a sudden you're under that 50 million gallons a day, and you're starting to look at actually 20 million gallons a day or under, now the media starts being a factor, just as far as your cost of operation, man hours, maintenance, the education of your operators. If you can throw a media at it for this, it seems to be a better fit. Cost of operation, CapEx, OpEx, these things all go into the factor. And if you decide that that is the route you want to go, running the RSSCT will actually establish your overall cost of operation. And there is a very simple way to get this done in less than 3 months. It's an inexpensive process, but it answers a lot of questions that I see in the design sector. You'll get to 90% and still not know your total operational cost if you choose to go down the media route. So that's the value of it. Okay. Where do you go to get your RSSCT testing? Obviously, we're one of the players in that. That's something we rent, we help, we do this every single day. There are other providers out there, and there is One Water out of Raleigh that specifically does this. Now you have to ship your water out, you have to send it to them, they'll run that, they'll get the lab. So there are other choices out there. If you want to do it on site, that's where you rent one of our skids. It's very easy to run, and we can walk you through that test. The basic choice is, do you want to do it on site or do you want to ship everything off to a lab? And there are plus and minuses for that, and you have to figure out what's best for you and your team. Okay. I know everybody's tired. I know this is not an overcomplicated part of the presentation, probably one of the most basics you've heard during this time, so I wanted to keep it short, sweet, and to the point. There is a value to RSSCT. It is underutilized in everywhere I go, and it is a clear first step if you choose that media is the way you want to go. It just helps out with establishing the effective removal in a very short period of time. That's my summary. I cut it down. Any questions?
All right. Do you have any questions? Okay, we got one over there.
Yep.
Not going to let you off that easy. I've seen these tests before. We've run a few of them in the lab. Have you had instances where, I guess my question is this better just to compare media side by side? So can you compare ion exchange resin ground with carbon ground with something like a FluoroSorb? And the second part is, have you actually tracked field systems to see how closely the RSSCT tells you what really happens in the field, 2 or 3 years down the road? How close are you in terms of the breakthrough in bed volumes predictively from the small scale column test?
Yes, a typical RSSCT that we run, our standard package, we run carbon, ion exchange, and FluoroSorb side by side. And it's no more expensive to do them side by side than just to run one. And a lot of times, because it's already, that's our standard skid. So a lot of times people go, oh, I was just going to look at, 2 different types of carbon. And we go, well, might as well, since we're doing it. And most people will actually take that step and consider something that wasn't even on the table. And we find a pretty consistent result across the board as far as bed volumes and everything along those lines. As far as removal rates, we know when the exhaustions happen. We've run probably 100 of this. I don't think that we've been doing this long enough to get that 3-year line, because we're still less than 5 years since we really started looking at this. And then in the last couple of years, I can say that full scale is probably plus or minus 15% of the RSSCT as far as exhaustion, breakthrough, and other things within that first year. Okay, but I don't have that multiple years.
Yeah, it'd be interesting to follow those and see how close the test predicts.
I do have some data from some customers
Mm-hmm.
that have done that testing, and I can pass on some information to you.
Okay, and then just one last technical
Yes,
thing.
sir.
So I imagine when you grind carbons, that's apples and apples. In terms of, I imagine a lot of this has to do with surface area, so the area that you have for sorption, and you got some internal sorption with carbon, but geez, an ion exchange resin is a kind of a different animal in terms of the structures and things. So do you guys calculate, do you go and calculate the surface area of those things so you know when you do your comparison that my surface area, my ion exchange resin is XX meters squared and my carbon is, YY meters squared?
That's exactly how we do it. And a lot of that comes from the manufacturer of whatever resin we're putting in there, is they understand and they actually prep the media for us so that we don't screw it up. Because,
Gotcha.
If we take it to a certain carbon grinder, it's a little bit different for ionic because of the cross chains. And even with FluoroSorb, they have their own calculation because it's an absorption media. So most of the calculations are linear based upon particle size, surface area, even though that the structure of containment is different.
Okay, thank you.
No problem.
Question?
Yeah.
So the nature of carbon and ion exchange breakthrough a lot of times is factored in by either channeling or compaction.
Yes.
So how does the what you're doing factor those
We eliminate
factors in?
that variable based upon the column. It's too small to impact any type of channeling or anything along those lines. So when you're doing like a bigger vessel, that's why there's backwashing in the way you process and distribute the water to make sure that that removal zone is homogeneous and can flow through it. Because if you do have it, you're not getting the surface area contact
Correct.
time that you need. So when you're in these little tiny vessels, there's no movement of the material at all.
Okay.
So you can't go, you have to go through it. It's forced through it. And that's why we can speed up the flow through it. And it's all about volume through it. There are hydraulic things that are not applicable to RSSCT.
Okay.
It is literally how much water can we get through as fast as we can until we see breakthrough. Because it's all about the absorptive capacity of the media itself. And because of the size and the compaction of it, we eliminate any type of hydraulic influence.
Any other questions?
All right.
All right.
We are
All right.
done.
Well, thank you, panel. If you all allow me just to make a couple of closing comments. First off, again, I'll be preparing everything that you've seen in PDF format. I'll make those available. Probably going to be next week before I get it out to everybody, along with the recordings. Thank you, Tim and Ralph, for all you guys do for our AV. Appreciate it. If you need continuing education credits, we've got affidavits of attendance out front. If you haven't already gotten one, make sure you turn those in. If you don't know if you've paid for it or not, don't worry about it. I'll figure that out and be in touch. And then lastly, I want you all to think about something. I don't need an answer right now, but in light of what we've heard over the last day and a half, 2 days actually, with a little bit of pause from a regulatory perspective, I want you to think, does it make sense for us to come back again next year for PFAS Forum 6, or do we give it a year? Wait and see what transpires from a regulatory perspective and what's going on with regard to research. I throw that out there. I need your feedback, so I'll send an evaluation form out to everybody, and I'd appreciate your input. Everybody have a safe trip home. Thank you, panelists.